Welcome to Callous Coder. Today a little bit more Zik. More beginner friendly Zik. Motherfucker! People seem to really like Zik and my videos about Zik. But one comment that came back a couple of times was, it's a bit too hard where you start. So today we do a bit easier. We will read a list of words, line terminated, from the standard in, and we will check whether they are palindromes. Now this is something I had to do for a little magic trick that I was working on. So you could swap the ends, etc. and give the illusion that you're mixing something and it's still the same. Not quite there yet with that effect. But I needed a whole list, so I downloaded a Dutch word list, because I need to do it in Dutch obviously, and set off programming it. I also added an English word list. When you have Unix or Linux running, under user share dict/words is a word list as well. This one is based on that, but with a lot of extra words. So let's jump in and have some Zik fun. So let's do some Zik coding. I created an empty directory called Palindrone. I already copied the two word lists in there, the Dutch word list and the English word list. Link to the code is in the description. So if you want also the code with all the comments that I put in there, then go there. But we're basically going to code this, and then we will speed it up with a new version that makes it about 5 times faster. So first let's initialize a new Zik project. So Zik init, and it will create a build Zik for you from scratch and a main, and let's start main. And first we clean out all the stuff that we don't want, but we do want to create some tests. It is a relatively simple algorithm, but it's kind of finicky, so it's good to have tests in this case. So these are palindrones. All right. Now how do you run a test? Let's just choose try in there. In the rest of this tutorial we're not going to use try. We're going to show you how to properly catch the errors. So try standard, and then there is a testing namespace. Object module, thank you. Expect equal. I like that one personally best, because then I can actually check in one if it's equal or false. And is palindrone Abba. Money, money, money. Waterloo, my Waterloo. I hate Abba. I hate Abba. Okay, palindrone. So this should be a palindrone. Let's also create one that actually ignores capitals, cases. And the same at the back. Always a good one. Oh, that should be a big A. Let's also check one with an odd number. That should actually work. And let's do a phrase with equal spacing. We will remove the spaces so that unequal spacing will also work. This is just a stupid thing, but and this one is a very infamous one. Was it a car or a cat I saw? That is actually a palindrome. And let's copy the test. So a test is really simple. It's even easier than in Zik. Test, and you give it a name. Are not palindrones. And that's it. So what is not a palindrone? Let's set these to false. The word head is not a palindrome. They're actually remarkably little palindrones I saw when I ran this. I was amazed by it. In Dutch we have a lot more. And a question mark. That should also fill. Now the squiggly is because we of course haven't yet implemented it. If you want an extra exercise, which is a good exercise, make one that actually removes the question marks, the commas, the dots, the periods. But we just stick with, for now, with only removing the spaces. Okay, let's set up our constants. We're going to read in from standard in. So this whole list we will actually push by cat pipeline into our program. So we need a standard in. I like the word standard in, so let's use that. And we get that from the standard io.get standard in. So instead of having to type this all the time, we can just use that. Same with standard out, and please use the standard out. I saw in my other video that a lot of people said, yeah, but we use debug. No, you don't use debug for printing. You use debug for error reporting. For printing, you will use the standard out, because then you can pipeline it into other programs without actually redirecting the standard error. So use the standard out for printing. If you actually want to print, use the standard out. And yes, printing can fail, and I will probably show you that. But that's why we will also catch the error. This is actually one of the few things that if you do a standard out.print that you can use try with in most cases. In our case, we can actually have a broken pipe. So we will actually capture the error. Okay, and then we will need an allocator, a general purpose allocator. So I will call that GPA for general purpose allocator, because we're going to dynamically allocate some memory for the new string that we create when we removed all those spaces. Because then we have a smaller string that we need to that needs to be filled. And if we do not actually clean it, we will have some junk behind it, and the length of the string will be different, etc., etc., etc. So we will just do it the clean way. We will just create a new string with the correct size. General purpose allocator. I don't want anything specifically named, and I don't have a lambda a function here to actually run. Okay, and then we can call create the allocator itself, const, and that is basically calling the GPA.allocator. So we have an easy allocator ready to use. And since we're going to work with buffers, let's create a constant buffer size, and let's make it 1024K. No word will be longer than that, even in the English language with weird names. All right, yeah. So let's first actually create the palindrone so that we know that it works, and then we will do the rest. Okay, so let's create this palindrone. Function is palindrone, and we will put in, what do we have here? A constant array of U8. So constant array U8. And we will return a boolean, whether it's a palindrone or not. Actually, we should return an integer over here, because we can also have an error situation, of course. But in case of an error, we just return false, because I know this error is really unique. Or we could exit the program as well. And how will we call this string? S. Let's keep it simple. Alright, so first we need to calculate the new size after we remove all the spaces. There is actually a function that removes a needle from a haystack. And it also has a function replacement size, so it will calculate for you the new size. So the type, well, that's a U8 that we're dealing with. And the input is, of course, our S. And the needle, well, we're going to replace all the spaces. But you can do this several times, of course. And also removing the dots, the periods, etc. And we will replace it with nothing, and it will return us the new size. That is really cool. And we have replacement without the size and an extra argument for the new buffer where it will copy it into. That does actually the work. So now that we have the size, we can actually allocate it. And this is what people always find difficult in languages like C and Zig in this case actually allocating memory, and it's not really that hard. It's just a matter of thinking about how much do I need. In this case we can actually pre-calculate it by running that function without actually doing it, and then asking for that memory. And it is of type U8 of course, and the size that we want is the new size. So now we have a chunk of memory of the new size, but this can actually fill. So you could do this, try, and it will actually satisfy it, but no, we're going to actually catch the error. And then we need a semicolon in this case, and we're just going to debug, and we will print out well, the error name that is generated. S for string, and then we need a comma and a tuple, so a dot, and I will use the error name, which will actually extract the error name from the error. And we can either do this, dot exit. I think we will do this. In my code, I actually, that is uploaded, I did a return, but an error in this case is actually a better solution, because there is no way that you can actually recover from it anyways. So let's just exit. Okay, and now we have some space allocated, but we also need to clean it. If we don't clean this, every time we create a new chunk, so 430,000 times, because there's over 430,000, oh, in this case only 140,000. I'm only halfway here. So around 400,000 letters in there, here. I need to add some more there. I did not copy it all. So we need to defer this and actually delete it. So the allocator then we call free, just like in C, except without the allocator. And the pointer that we want to remove, this. So as soon as this goes out of scope, it will first call a free for us. Very, very simple. See, memory management isn't hard. Now we're actually going to do that whole replacement, because we have a buffer now that is large enough to actually capture that new replaced string. So replace, and we will just copy what we already had here, and we add that pointer on the back. So comma, spaces removed. All right. Yeah, and we do not capture the size here. That is how it has been changed. I don't care for it anymore, so hence the underscore. Okay, so now we removed all the spaces, in case there are any. So now we can do our magic. Now I urge you, if you never checked how a palindrome is created, or checked for, to actually pause the video and have a play around yourself. Because programming, the majority is actually coming up with these solutions. So if we have the word Abba, Waterloo, Waterloo, all right, then how do you check? Well, that's actually really simple. You check first, you read the first letter and you check it with the last letter. The second one, the second letter, and you check it with the second to last letter. If we have something like this should also be a palindrome. You see, we should only actually count this half the size of the string. So in this case it's 5. 5 divided by 2 is 2.5, so 2. And that is really how simple it is to check for a palindrome. So we're going to count from 0 to new size divided by 2. Yeah, because we only need to check half the string. Capture the I. The I in this case is 0, 1, 2, 3, etc. And then we're going to actually check. Now we need to do something first, because we can actually check if the characters are already different, but remember that we still had this situation. We can have a capital A. And for reading, that is, well, basically the same character. So we first need to convert those characters to lowercase. So the temporary start character is actually standard, and we have the ASCII module, and that already has a to lower. Actually, I found it out yesterday when I wrote this, because I first wrote my own to lower script, with an or 32 if the characters are between the range of a capital. And then I ran my Cody, and Cody said, hey, there's actually an to lower for that. I was like, oh, that's cool. And he was right. Cody is, by the way, a great assistant. I currently haven't it running over here on this machine, because otherwise it would fill out 80% of what we're doing. Alright, so we need to say from the spaces removed string, the I we will actually turn to lowercase. And the same with the temporary end string. And that is the new size. So we want the end of it minus the current offset. And of course -1, because arrays start from 0. So if we are checking position 2, we're checking the end position -2. So that's actually correct. And then the -1, because arrays start at 0 and links not. And then we just need to compare them. If TS not equal to TE, then we immediately return a false and break out. And otherwise we return a true. Okay, so let's see how many bugs we have. Zig test source main, because we have the tests in the main. It's compiling and it has an error. Oh, it fails. These are Palindrones. A man. Oh, I see it. This one is failing. It's a NEM. That should then actually work. Yeah, both tests passed. Alright, so now we just need to write reading from the standard in. We checked our logic. Cool. So we need a reader, a standard in reader. So let's do a standard reader. And I want my reader to be from the standard in. And we just obtain that reader. Now I want to turn it into a buffered reader, because the standard reader is really slow. It works character for character, I think. And a buffered reader uses a buffer. So let's use the standard.io.buffered reader, and it will say, give me a reader. Hence, I needed to obtain the reader there. Reader. Standard reader. Standard reader. Yes, this one. We also could have done, of course, because we only use it once, standard in dot reader. We could also have done that. Maybe let's do that. That's a bit smaller. All right. And now we need a buffer to hold our string. So that's going to be a variable buffer, not a bugger. And let's have the buffer size that we had. And it is, of course, of type U8. And we always need to define it. But since we do not know what is going to be in there currently, we just call it as undefined. And then we will do a while loop, while something, and that while something is a BR, so the buffer reader. We use that reader dot, and this is a cool function, read until, yeah, there we go, delimiter or end of file. So we will read from what? We will read from the buffer, and that is on the stack, so I need to put the pointer in there, so make that ampersand put in there. And the delimiter, well, obviously the delimiter is the new line. Okay, now this can fill. So we could get away with doing a try, but let's not do that. In this case it probably always works, but let's be good, gentle boys. And let's catch the error, catch error, and let's have a little block there, code block, and this is where the debug.print is very useful for. We had an error, it is S and comma, get my tuple, and I want that error name, because that tells me a lot from the error already. Okie dokie. And in this case as well, I cannot do anything. So let's use the standard OS exit 1. Because if my buffer reader already fails, then yeah, nothing to to regain. And now, of course, if it isn't an error, we can actually capture the line. So capture L. Don't believe all those noobs that say you need to have long variable names. Fucking nonsense. Everybody can see that this is captured over here and that the L stands for line. I don't need line in there. It makes no sense. So let's check if it is a palindrome. Palindrome. Yeah. And then, of course, we need the L in there. And again, we're going to open some squigglies. So if it is a palindrome, then we actually print it to the screen. Standard out. That's why we created that on the top. Print. And I just want to print the S with a character return line feed. Because the line feed is removed. And let's obtain it from the line. And also this can fill. And this can actually really fill. So let's catch an error. I hope I don't forget, but then I can show you that it will fill. Because we're inside brackets, not roundies like we here. We need that semicolon. And then we do the standard debug again. Print, well, same thing, error. S, new line, comma, tuple, and get me that error name that actually comes from it. In this case, it is probably a broken pipe that can happen. And then also just exit out of it with a 1, because there's nothing we can do. And otherwise we print it. Yeah, that seems to be okay. So let's test this. Cat English words pipeline to zig build source main. Actually, oh, zig run, not zig build, because then it will actually create. And we have an error. Expected a U8. Found constant. Actually, that is allowed. Oh, I see what I did wrong. It's a character, not a string. Where, there. These should be single quotes. It's a character, not a string. And it actually tells me that. Alright, what else do we have wrong? Standard out of print. No field member print. Oh, I forgot something here. Yes, I forgot the writer behind it. It's writer.print. And there we go. So we've got it, but it's a bit slow. I mean, these are, how many lines did I put in there? Only 466,000. And it takes quite a bit of time to actually go through them. So let's time them. Let's time them. And it's a bit slower because obviously it's running as a zig build with debug. But it's terribly slow. Python people might be happy with this, but we aren't. So 6 seconds, 6.5 seconds. It's ridiculously slow. So how can we speed this up? Let's make a fast version. Let's copy this. Copy C, copy V. Rename. Because it perfectly works, and if this is what you need it, then it's the speed that you get. But we can actually speed this up. And first we need to analyze what makes it slow. Which also makes it safe, by the way. That is this part. The allocation of memory and the freeing of the memory. That really takes a long time. So can we actually speed this up? Well, we could use a fixed buffer. But fixed buffers always have the danger of actually overrunning. But in this case, I think we can do something that pretty much solves that. So let's create spaces removed. and that will be of type array U8. Okay, let's create something called P, that is the size of a buffer, and let's put that in there with the brackets. Let me fast forward and do it all here as well. I don't know how to actually do this in Visual Code. I don't really use Visual Code a lot. Okay, let's run the test. Where is my zig fast test? There, zig test, zig fast. Okay, still passes, it works. Now let's run in that list of words and see how much faster it goes. Look at that, in 1 second 14. That is a great deal faster because we eliminated the whole memory lookup. But what if we now actually do this? Let's say we make it 2 bytes and we run. Oi, we have a buffer overflow. That is a very, very bad situation. You don't want this. We can actually capture this by just doing a simple statement. If l.len is larger in this case than 2, then we continue to the next word. So if there is a word that is larger than 2 characters, then we just ignore it. We do not push it in. And look, that works. So if we then put the buffer size back in there and back in there, we actually safely sped it up 5 times. And idiotic large words that are bigger than 1K, well, we're not interested in those in this case. So yeah, that just works. Now also let me show you why we did the error handling here with the print. Because if I actually run a grep statement that is wrong, so grep asterisks, it will break the pipe. And now you see we actually get a sensible error, broken pipe, and we'll exit from it. And that is why we catch the errors with a standard print. A lot of people don't know that actually prints can break. And yes, they can, especially in this situation where you pipe them to other outputs. So it's always a good practice to check whether prints actually succeed or actually have a catch in other languages for these sorts of broken pipe errors. So there you go. And if we just do this, grep Abba should still be in there. Boom, yeah, we found Abba. So yeah, that works. So there you have it. We wrote a nice little zig program to get all the palindromes, in my case from the Dutch language, and I found a couple of interesting ones. One that I really liked that I never really realized, oh my goodness, that's a palindrome, is DigiD. We use that in the Netherlands for all our governmental affairs. So paying your taxes, you have to log into DigiD. Your governmental mailbox, you have to log in with DigiD. And I was like, oh my god, that is actually a palindrome. That's clever marketing. I never realized it. I use it like a couple of times a year. Never saw that it was a palindrome. So that's kind of cool. We also learned that memory allocation is a slow process because you need to go to the kernel. It needs to do a lot of work. And that if you can pass in fixed buffers, it will speed up things a lot. Obviously, with that caveat, the same with C and C++, that you need to safeguard your boundaries, your memory boundaries. And I think we did a nice little workaround to actually speed it up almost 5 times. And yeah, Zig does already help you a lot with memory management, with the defer, etc. But you're still managing your memory yourself. Which in certain cases is really great because you have that full control to speed things up this way. In Rust it needs to be safe, so it's done in a certain way. And when that ends up to be slow, then yeah, it is a bit slow. But it is safe. In this case, we made it pretty safe because Well, who needs a word that's larger than 1K anyways? So we know that this will just work, and it's really, really wickedly fast. So yeah, some palindromes in Zig. I really like Zig. Now, frankly, if I had to do this myself and I didn't think about creating a video, I would have done it in Python. I don't care if it would have taken 30 seconds to go through the whole 400,000 plus Dutch words. I would have been fine with it. I would have knocked it out in like 2 minutes. Now it took me a bit longer, but I had a nice video as a result for you guys. So I hope you learned something and see you in the next one.